The purpose of this video is to do the problem numbers. Let's see, you guys asked for 17, 18, 22, and then there's a few other ones, and I'll get to those. So anyway, this is from the derivative worksheet section, from the section where you had numbers 1 through 24, and I think on the homework number 8, I referred to this as the derivatives problems worksheet. Okay, so anyway, there are a few of these. We're not going to go through each of them in detail, but because really what you need to do is you need to rewrite the problem down and then go through the steps, look back at the solution, and then keep doing that until you can go through the steps without having to look at the solution. But a lot of this is just algebra. So we know that the derivative of the y cubed is 3y squared y prime, and we should know that the derivative of negative ln of x is just negative 1 over x. Okay, so solving for y prime, we get this guy right here, negative that expression, and then, well, we have a quotient, and so we just take the second derivative. To find the second derivative, then we would take the derivative of the left side, it's y double prime, and the derivative of the right side gives us this right here, and simplifying that we get a more simplified version of that. Now notice though that we have this y prime in our answer. Well, you have to put what y prime is equal to, and that's this guy right here. Okay, so this right here is what you're going to replace y prime with in this equation, and so then, or in this expression, so then you just basically you're finding the second derivative of y with respect to x, but in terms of only x and y and not having any y prime in there. So maybe that's what threw you off a little bit, whoever asked for this problem, or whatever students did. And anyway, it's just a lot of algebra, which is kind of a mess, but nevertheless you're solving for y double prime. Okay, let's look at the next one. The f prime ones, where you're trying to find the derivative of f inverse, things like that, those won't be on the test. I'm not going to cover that now, I'll cover that later. So 18, we'll cover that later. Number 22, for what values of x is f of x not differentiable? Okay, well the kind of like the sucker answer would be when it doesn't exist, so f of x doesn't even exist at negative 2, so for sure it can't be a, and it can't, well, it can only for right now not be a, because a doesn't even include negative 2. You can't have a function differentiable where the function doesn't even exist. Okay, well, it is a bit of a messy derivative. Nevertheless, we have to take the derivative, and then when you simplify the derivative, you end up getting this expression here, which you can clearly see includes a factor of x minus 1, and so therefore not only can x not equal negative 2, but x cannot also equal, x is not allowed to equal positive 1. So we say that x cannot equal positive 1 or negative 2, and that's choice C. Okay, so again, lots of algebra, and hopefully your algebra is becoming stronger if it wasn't strong to begin with, but that's what's going to keep you from passing calculus is the algebra. It's not the calculus, it's always the algebra. So hang in there. Problem 2 from that same section, the derivative problems worksheet. We're going to cover this later on in the course, and you know, some of these problems I think I even mentioned, if we haven't really covered that in class, then you don't need to worry about that in terms of doing it for the homework and getting ready for the test. So don't worry about that one for right now. This one though, I like this. Let me clean up this page and then I'll get right back to you. Okay, I just didn't want to have the solution there. I thought the solution was a little bit messy. We need to figure out where on this graph is the tangent line vertical. In other words, where do we have the derivative not existing? So let's find the derivative first. Y prime equals 2x plus, so the derivative of negative cosine y is positive sine y times y prime. Okay, and then we're going to go ahead and subtract this term from both sides. We're going to subtract y prime sine of y from both sides. So the goal here is to figure out when y prime doesn't exist, and when y prime doesn't exist, that's where we'll have a vertical tangent line. Okay, so we get y prime minus y prime sine y equaling 2x, and then if we factor out a y prime, we get 1 minus the sine of y is equal to 2x, and when we divide both sides by 1 minus sine of y, we get 2x over 1 minus the sine of y. Okay, so for what values of x in the interval 0 to 2 is the tangent line to the curve given by the parallel to the y-axis? Okay, well, we need to figure out when y prime doesn't exist, and when y prime doesn't exist, when 1 minus the sine of y is equal to 0. In other words, when the sine of y is equal to 1. Well, what does y have to be for the sine of y to equal 1? Well, y has to be equal to pi over 2. Well, what causes the y to be equal to pi over 2? Well, if we want to know what causes that, then we have to plug in y equals pi over 2 into the original equation. And yeah, I agree, this is a tricky one, but pi over 2 equals x squared minus cosine of pi over 2. Well, we know the cosine of pi over 2 is 0, and so then we get x squared is equal to pi over 2. Well, if x squared is pi over 2, then x must be plus or minus radical pi over 2. But we're told that x has to be on the interval from 0, is it from 0 to 2? Yeah, from 0 to 2. And the only value that we got here in between 0 and 2 is radical pi over 2. And so that's our answer. B. There you go. See if we have any other ones. Nope, that's it. That's it for this video.